This is nutrition video number 3 for my Nutrition 300 classes, sorry. So when you talk about digestion of dietary protein, we've actually covered a lot of it already. Fat was a little different because we hadn't talked about bile and breaking the triglyceride into the monoglyceride and the 2 fatty acids. But we did talk a lot about protein because that's a good chunk of chapter 3. There is no enzyme in the mouth. There is a pepsin inside the stomach, but you can't cut anything until you denature something, right? So, here are your 20 amino acids all mixed in there, 9 essential, 11 not. They come in, you add acid, you uncoil. We could do it with heat. We could jump up and down real fast. We just happen to do it with acid. And then pepsin can start chopping things up. And it kind of works like here, right? So we've got our giant molecule coming in. We denature with acid, HCl. We use pepsin to chop. Smaller chunks come into the small intestine. Now, the pancreatic juice has its own version of pepsin. It's called trypsin. It's actually called trypsinogen. That's what's made in the pancreas, but when it's exposed into the conditions of the small intestine, it becomes trypsin. Trypsin has a sibling called chymotrypsin, and all these basically do is further chopping. So if pepsin is the lumberjack, trypsin is the person at the wood mill chopping the giant logs into even like boards and planks. And then finally you get down to single amino acids or double amino acids. Now a double amino acid, 2 amino acids attached together, is called a dipeptide. That's the bond that connects the 2 amino acids. There's an enzyme on the wall of the villi. So there was maltase and fructase and maltase, sucrase, and lactase. There's also peptidase. And peptidase actually cuts that double molecule. And what comes into the body mostly is 99% single amino acids. It doesn't matter what protein it was. You uncoiled, you chopped up, and what's coming in are individual Legos. So you eat the Lego Death Star, you get all the little parts, and then you want to make yourself out of Legos. That's kind of how it works. And these Legos flood into the bloodstream. In fact, if you looked in the blood, you would find a whole bunch of new Legos, new amino acids that came from diet. And then when cells die in the body or proteins break in the body, we can disassemble those amino acids, those proteins in our body, and then free up old, if you will, I hate to use the term, but used amino acids. So in the blood you have, and we call the blood the amino acid pool because it's a giant pool of amino acids, new ones and used ones. I think that's the best way to say it. So what do you do with it? Well, number one is you're going to build your body. Some of those amino acids go into the body. We call that synthesis. Some of those amino acids come from the body when the body breaks down. We call that degradation. And we feed amino acids into a cycle. It's called turnover. You're kind of turning over tissues. If this was the sports nutrition class, I would argue that athletes need more dietary protein, again, not to build more muscle, just because they use their muscles so much more. It's like a race car and you're throwing parts into the race car. Athletes have greater turnover. Now, you could make some glucose from the amino acids. We can do that during ketosis. You could just burn the amino acids in muscle cells for energy. And if you have excess amino acids, you're just eating like a ton of dietary protein, and you can't store them anywhere, you will convert extra protein to fat. Usually we don't eat that much protein. Usually for us, it's carbohydrates. But still, you get the point. Let's talk about turnover, though. That turnover is the vast majority of the use of dietary protein. So we got this thing called turnover. It's a sum of what's going into the body, what's coming out of the body. Those who have the most turnover are turning over their body. Athletes, injured patients, people who are going through growth like puberty or infants, pregnancy. Those folks are just using a lot of amino acids, and in the process, a lot of their body is breaking down too, so they have a very high turnover. They're going to need more protein from their diet, not because they're building more, they're just using stuff more. Now, you always do lose some protein. Proteins break down, you lose hair, skin falls off. When proteins do break in the body, we disassemble them, we try to get the amino acids, we try to disassemble the amino acids, and then pee out the nitrogen part of the amino acid. That will become ammonia. If you've heard of ammonia, it's some pretty nasty stuff. The liver will convert that, I believe, from ammonia to urea. And urea is this combination of a couple nitrogens. Is that 2 or 3? I forget. Anyways, and then the kidney takes their urea and puts it into your urine. So what you kind of smell in your urine is urea. It's the nitrogen compounds, the nitrogen coming from broken amino acids, which are coming from broken proteins. Pretty cool. Okay, so here's our pool. Here are all the amino acids. Some are new, some are used, some came from broken body. Some of those go into the body, some of those come out of the body. There's your turnover. Now, it's hard to describe turnover. We just know that really active people have more turnover. Look, it's been studied. They've used radioactive or radio-labeled amino acids, feed people like radioactive steak and see how long it stays in the body, et cetera, et cetera. Just take my word for it. Turnover is a thing. But what we can measure in everybody is how much protein they eat and how much they excrete. Now, it's a slightly complicated, though, because measuring individual amino acids is complicated, and we don't really do that. Instead, we track the nitrogen. Remember I said a couple of videos ago, on the plate, nitrogen is in the amino acids, and the amino acids are in the protein. So if you just measure nitrogen coming in the body, it can be done, and you measure nitrogen leaving the body, now that's mostly going to be in urine, you can ask a question. Does the nitrogen coming in, all the new amino acids, equal the nitrogen leaving, those that were used and broken? And if you're a race car, wouldn't you think, if I'm losing parts in the garage, am I ordering new parts to the garage? Don't you want to use new parts to replace parts that broke? We call that nitrogen balance. It's a balance of nitrogen coming in, protein, really, and nitrogen leaving, which is another measurement of broken protein. Now, we say you're healthy, you're not losing weight, you're not gaining weight, you're kind of like in your adult equilibrium. If nitrogen coming in equals nitrogen leaving the body, again, nitrogen is a marker for proteins and amino acids coming in. If those are equal, you eat what you lose, which is what you would want to do. And if you're a big muscular person, you probably pee out a ton of nitrogen, which means you need more. And if you're not a muscular person, you probably don't pee out a lot of nitrogen, so you need less. And if you're not a super muscular person, but you're a long distance runner, you probably pee out a little more amino acids than everybody else, nitrogen, and so you need more coming in. That gets into that turnover idea, right? So if you lose 2 hot dogs on Monday, your pool of amino acid, what you could do and build and grow and repair with, excuse me, in the blood would drop. But if you eat 2 soy hot dogs on Tuesday, you eat what you lost. You're in equilibrium. Most adults are, if you're healthy and you're not losing or gaining weight. That's the caveat. And then finally, here's a way to look at it, right? If you are in equilibrium, you eat an amount of nitrogen that you lose. If you are eating more nitrogen than you lose, wait a minute, how's that possible? That means you're storing protein in the body. Those amino acids with nitrogen are staying inside. Well, how's that possible? You're growing, you're pregnant, you're doing recovery, you're adding muscles. Anytime you go through a growth phase, you're accumulating protein in the body. You're accumulating nitrogen. Anytime on the other side you're injured, you got the flu, you broke your leg, you got COVID, right? You're not eating. Well, if you're not eating dietary protein, you're not eating nitrogen. That doesn't mean you're not breaking down your body. This turnover idea, that continues. Sometimes when you're sick, it's even higher. When you get the flu, you can burn through your body really quickly. So when you have negative balance, you pee out more than you eat. Usually you're losing protein from the body. Most humans have positive periods of their lives. We get injured and sick in the flu. We have negative periods of our lives. Our goal is typically to be in equilibrium. Eat an amount of protein that we lose, and we measure all this just tracking the nitrogen, which is in the amino acids from which we build the protein. Nitrogen in compared to nitrogen out. Nitrogen balance.